So the last kind that you're responsible for and that we want to look at are on page 44. They're mixture problems. So anytime you're going to mix two things together, this is probably the format you want to use. And some of you may be doing some of that if you're going into a medical profession. So let's take a look at this one. It says a refinery has 7,250 liters of a gasoline methanol blend that is 6% methanol. How much pure methanol must be added so that the resulting blend is 10% methanol? Now, you need to make sure again that you understand what's happening here. Let's say you're taking a container and you're pouring pure methanol into something that is only 6% methanol, and you're trying to get it so that it ends up being, when you're finished doing all your pouring, 10% methanol. So that's what's happening here. And so when we take a look at this, we have got a container of pure methanol. And so I like to draw, and my drawing is horrible, but for something like this, I like to remind myself of what I'm doing, and I like to draw little containers, little beakers. So that's my little beaker, and I know that looks horrible, but I'll label it as pure methanol. And I'm taking another beaker that is 6% methanol, and I'm adding those two together. You know, I'm pouring them together. So this one is 6% methanol. And I'm mixing those two together, and I'm trying to come up with a container when I'm finished that has 10% methanol in it. Now, going back over here to this one that's pure, when something is pure, it means it is 100% of whatever you've got there. Now, when you look at these two things, what you're looking at is you have a certain amount in this container, a certain amount in this container, and you're going to pour it in this container so that the percentage will match. But you also have the liquid that's in there too. You know, you have maybe 5 ounces of something and 4 ounces of something else, and you would have 9 ounces total. So you got to look at that when you're looking at mixture problems too. So when I go back and I look at my problem, it says the refinery has 7,250 liters of a gasoline methanol blend that is 6% methanol. So I know when I look at this container that it has 7,250 liters in it. I know that for sure. It says how much pure methanol must be added. So when I look at this one, I have no clue as to how much I need to add. In this one, all I know is that it has an X amount and that it's 100% pure methanol. This one's 6% methanol. That's all I know in those containers. But this one, if I pour everything I need from this one and everything I need from this one, what I know about this container is not only is it 10% methanol when I'm finished, but it has the 7,250 in it and whatever I pour in it. It's got that total amount in it. So I do know that. And when I look at these containers, if I draw my containers correctly, I get my equation from that. Now, when I take a percentage of something, like if I had 45% of 7, I would do 0.45 times 7, and that would get me my percentage. That's how you take a percent of something. So, if I take 100% of X, 100%, when I do math with it, I have to move my decimal 2 places to the left. So I would do 1 times the X, and that would give me my percentage. In this other one, I would do 0.06 times 7,250, and that would give me my percentage. In the last container, I would have a 0.10 because I moved my decimal 2 places, and I would have a 0.10 times 7,250 plus x. Now you should be able to solve that equation, but we're going to go through it anyway. Just keep in mind when you're doing mixtures, if you get these containers drawn correctly, all you have to do then is take the percent times the value, the percent times the value, the percent times the value. That's all you're doing when you're mixing things. So let's take a look at this math. 1 times x is x. If I take my calculator and I do 0.06 times 7250, I get 435 equals, this 0.10 would need to be distributed, so 0.10 times 7250 is 725 plus 0.10 times x is 0.10x. Now this is basic algebra from here out. I need to get my x's together, so I'm going to pop this one over to this side, and I'm going to do 1x minus 0.10x. So 1 minus 0.10 is 0.9x. I'm going to pop the 435 over here. So 725 minus 435 is 290. And then I'm going to divide both sides by 0.9. So 290 divided by 0.9 comes out to 322.22. So I'm going to put these squiggly equal signs to show you that I've rounded. So 322 liters is what I would need to mix with it in order to get that. And I want to make sure that I have everything that I need in those containers. I could go back up here and I could check it by putting 322 right here and make sure that it came out to what I needed. So you can check these by going back up and plugging it back in. But that's all I need to do for this one. If you have questions, make sure that you contact me and make sure that you do the practice that I suggest as well.